perception, planning, and control. This is a sort of a lab course, and you will be designing an intelligence for a robot. Okay. There will be 4 professors involved in this course, and 10, I think there's 10 TAs. And I'm this person here. My name is Chang. I'll be in charge of this course, and I'll be teaching intelligence. There's Professor Myung-hyun, who will be teaching you about SLAM and ROS, which is a robot operating system. There is Professor Kim Min-jun, who will be teaching you about robot manipulation. And Professor An, she will be in charge of teaching robot planning. Okay, so there is SLAM, but robot manipulation, planning, and artificial intelligence. Okay, some computer vision, reinforcement learning, and LLM. Okay, and there are 10 TAs, and let me introduce the head TA, Kim Won-hee, if you can stand up. Okay, so if you have any problems, if you have questions, you can get in touch with him. Okay. All the lecture notes will be uploaded on the KLMS, okay, including lectures of the video. Okay, video lectures will be uploaded. Okay, so let me just exactly define what this course is going to do. This course combines theory. The professors, the lecturers will provide the theory, and you will have lab sessions to practice the theory, okay, to equip students with the skills to design robot intelligence. So it's robot intelligence. You're not here to design a robot, but the intelligence that goes into the robot that integrates robot manipulation, robot planning, and artificial intelligence. And the robot intelligence will include computer vision, large language model, and reinforcement learning. Students will develop robot capability of autonomously performing diverse tasks, operating reliably in an unstructured, non-standardized environment through effective perception, planning, and control. And I'll show you an example of the task that was conducted last semester. Okay? And you'll be taught robot operating system. That's called ROS. And I think we will focus. There's ROS 1 and ROS 2. We'll focus on teaching you ROS 2. We'll also give you or introduce SLAM, which is simultaneous localization and mapping. So it maps out the environment to tell you where the robot is within the map, within the environment. Okay, and we will be using YOLO, which is a detector, computer vision detector, to tell you where you are and tell you a little bit about, or tell the robot about the environment. Planning, as I said, you will be given an environment, and the robot will be placed randomly in that environment, and the robot will be asked to perform some task, and the robot will need to plan out, okay, to perform this task, okay? So there are various ways to make the plan. You can use an LLM, okay, and there are various algorithms for planning to perform that task. And you will learn a little bit about control. It's robot manipulation to do certain things, and also reinforcement learning. Please ask questions. Please ask questions. So this course is probably the only course right now for designing robot intelligence, okay? And why it's a new course, it's a new lab course. The first course in this of this topic was given last semester, and the reason why we did this was that AI is advancing, and robot is advancing. So you can see this robot; it's almost running around like a human, maybe even better than a human. Okay, so right now the focus of this world right now is to put intelligence in this robot. Okay, and of course, LLM is used everywhere, so you will learn to use LLM to help you perform this task. Okay? And there is a word for this, intelligence in a robot, that's called physical AI. Okay, so this course is about physical AI. And the robot is given to you, and you will be designing the intelligence. So, as I said, these videos that I'm going to show you about robot are probably exaggerated. Their movement is not so smooth, but you can see. You can do tumbling, back tumble. This is G1 from the company Unitree. This is Optimus from Tesla, And this is Atlas from Boston Dynamics or Hyundai Motors. Okay. These robots would cost a little bit less than $100,000, okay, these days, and the prices are really coming down, okay. Some of these robots can be bought in Korea, but still, for you guys or for us, it's the price of these robots are out of our reach. It's too expensive. So instead, we will be using this robot right here. Okay. This robot would cost around about $2,500, $2,000 to $3,000. Okay, so it's not a really cheap robot, but it's not a really expensive robot. Okay. So you would be, placing or designing intelligence for that robot there. Okay. Artificial intelligence has advanced greatly, and in terms of perception, seeing the world, you can see that we can do object detection very, very well. We can also do segmentation very well. So what is segmentation? It's classifying each pixel as one of the objects. Okay, so for instance, any of these pixels here, let's say I pick that pixel, that will be a pixel belonging to the dog. And that will be a pixel belonging to the head of a person. Okay? And that each class is color. So you can see that all of these pixels here are colored the same. Okay? And by looking at this color, you know that each pixels are correctly classified. We also know that planning has come a long way. AlphaGo is planning. Okay, you're planning many, many steps ahead. Autonomous driving is here now. Okay, some of those cars can drive right now fairly well without the help of a human. And, flips that you saw, dancing, those are all control. Okay, that's all control. So we want to combine all of this, okay, and do it autonomously. There is LLM to do a lot of these things. LLM can do perception. LLM can do planning. LLM can also do a lot of control. Okay. But if you, ask LLM to do all of that, it would be very, very costly, and also maybe unnecessary, and there will be some delays. Okay. But there are many, many LLMs. LLMs were first developed in 2018. Okay, and now it was about 110. There were 110 million parameters. Now there are trillion. So over the period of 7 years, the complexity of these LLMs have, is 8 times, increased by 8 times. Okay, and what that means is that they have become more sophisticated and they have become more intelligent. Okay, so in this course, you can use LLM to do many of the task, to help you out with a task. Okay. So where are we right now? Oops. So there is this company called Figure, and they have a robot. This is the 3rd generation, Figure 3. And they have been collaborating with OpenAI. So there's the robot, machine, and OpenAI provided intelligence that goes into the robot. It's the first time I'm watching this video actually, so I'm pretty... So very soon, instead of buying a car, instead of, you'll probably have one of these robots at home. So the man shopping, and it's asking the robot to do various house chores. Wow. So it's cleaning up the house. So there's a lot of intelligence going into it. It sees these things and recognizes where it should be. Okay, and what it needs to do. These are random things, random objects. It knows where to place them. And it it's able to, wash these dishes, place the right amount of pressure, and it requires a considerable amount of dexterity to these things. And intelligence also has to relate with the action of the robot. Okay? You're probably familiar with intelligence and relating it with text, words. Okay, so we'll stop right there. Fold. Okay. Yeah, so physical AI is, or sometimes it's called the embedded AI, refers to the integration of artificial intelligence into physical systems such as robots. I mean, I've shown you just robots, but drones, vehicles, and other machines. Okay, so intelligence, you're mapping intelligence to action. and it has many uses. Okay. And a person who first came up with this word physical AI, lots of people like to use this embedded AI, is this person, Jensen Huang, the CEO of NVIDIA, I guess. Yeah. So this is the progression. In 2012, we had AlexNet, which is able to classify 1,000 objects, okay? And it was the first time GPU was used to learn the objects, okay? And that progressed to perceiving, doing speech recognition, object recognition, medical imaging, doing a lot of classification tasks. Okay, so that's perception AI. And then the AI can also now give you text. It can also give you images and videos. You've probably seen these things. And AI advanced to do agentic AI. Agentic AI is an AI that is able to use tools, okay, tools such as Explorer, using Word, using calculators, that sort of thing. Okay, it's able to use various tools to do perform various tasks. Okay, and it uses these tools to do the task autonomously, and that agentic AI is placed into a physical system, and we call that physical AI. Okay. So what you're designing is probably similar to agentic AI, okay, which will go into that robot. So there's the real world, okay. There are various sensors. There are RGB camera, LiDAR, and there are various algorithms. We'll be teaching you SLAM, YOLO to do detection. There are also various vision language models, okay? And they will be post-processing the censored signal, okay? And based on that, it would make a plan to perform the task that it needs to do, okay? And it has wheels, joints, and motors, and it needs to control that, okay? And then it's interacting with the world, and it's probably getting feedback as well. And the whole platform is on this ROS, okay? So, you use Windows, you use, OS, various OS, and for controlling the robot, you have ROS, okay? So this course teaches how to design intelligent behaviors for robots, utilizing and developing and learning the latest artificial intelligence, okay? So you would be actually learning how to train an artificial intelligence, okay? And also using various programs, you would learn how to do all of these things, okay? Students will be provided with a robot platform. This platform right here And you would be also provided with the operating system. You would also be taught SLAM, but there are SLAM algorithms that you could just use. And you can do video recognition. There are programs to do video recognition, and you can use that to map out and also find out where you are, where the robot is, where the robot can find out where it is. So it's essentially training AI algorithms and also integrating various algorithms that you have trained or that is publicly available. Okay, and you'll be given a task to solve real-world problems. I think I have a video at the end. Let's see, is there? So this is what the students did last semester. We call this the agent or the robot. Okay, the agent has no prior knowledge of the environment, so it's placed in an environment that it's unfamiliar with. And it first finds a map of the environment. And the environment is divided into several zones. Okay? And there are images and colored cubes in the zone, and the robot is given instruction about the placement of the cubes. Okay, and yeah, you'll see it. Okay, and all of this needs to be. You give it a verbal instruction, and the robot performs the task autonomously without any human interaction. Okay, so, oops. Let's. Okay.
Place the red cube in the zone with the sofa and the blue cube in the zone with the cat.
So here again, the robot is placed in an unknown environment that is divided into zones. And if you look at the zones, there are cubes, colored cubes. And each room or each zone has a distinct marker, and here there's an image of a sofa. So this zone is identified with the sofa. There's another zone with a picture of a cat, and this zone has another picture of something. Okay, and you give it this verbal instruction. Place the red cube in the zone with the sofa, so that cube needs to go here, and the blue cube needs to go here. Okay? So it's this environment. The agent or the robot had no knowledge of the environment, okay? And it's seeing this thing for the first time, and it needs to do this, okay? So it's going to each of the zones to figure out what's there, the picture. It's trying to identify the zones, association with the picture. And it needs to do that. We had 11 teams participating last semester. And guess how many teams succeeded? Only one team succeeded. Only one team succeeded in doing this task. Okay? But this is pretty incredible, isn't it? Oh, it's pretty incredible. The course should have prerequisites. So we're expecting, we cannot teach you everything. Okay? So we expect that you have certain programming capability, okay? 209, and then you have basic knowledge of signals and systems. The algorithms, artificial intelligence require, having some knowledge in probability, okay? And I'm assuming that you had certain introductory level artificial intelligence. Okay, obviously I cannot teach you everything. Okay, so 331 was a course that I taught last semester. Okay, and if you have taken that, then that's right. And 381, which is control systems for doing control or manipulation. And of course, this course is a senior level course. So signals and systems, a little bit of probability, programming, and artificial intelligence. Okay, we expect, and I'm sure that most of the students who are taking this course have far more experience than these whatever's taught in this course. Okay. This is probably the most important part. How do we grade you? After each lecture, excluding today, there will be a lab session. Okay, the lab session. We have sort of a timetable for a lab section, a certain day. Each of the lab section is going to be worth 5 points, and there are 9 lab sessions. Okay, and the lab sessions are all geared towards finishing the final project. Okay, so we won't be giving you lab tasks that is irrelevant in doing your final project. Okay, so you'll go through 9 lab sessions to learn bits and pieces of the intelligence that you need to design for doing the final project. Okay, so that's 40%. So it's 5 times 9. That's 45 actually.
Yeah, 45.
Sorry about this. It should be 45. Okay, right? Right. So let me just change. Okay. And the final project will be worth here 60, but probably 55 will be the correct thing, right? So 45, oh, and 60,
45, final project 45, and attendance for 10%.
oh, attendance 10%. Sorry, so we need to modify this, okay? Okay, everyone get that? Okay. There are 9 lab sessions, okay? Teaching you about ROS, teaching you about SLAM, teaching you about planning, teaching you about robot manipulation, teaching you about detection, segmentation, LLM, and what else was there? Reinforcement learning, okay? And I think there are about 9, and times 5, that's 45. Then you have also the project is 55. No, actually, it's 45 times 55, that's 100. Okay, let's make this thing 45 and that's 55, okay? And I don't think attendance is important, okay? So sorry about this. So the lecture will be given here, okay, every Friday, 4 to 5:30, okay? I'll try to finish 15 minutes ahead of time so that you can go to your next schedule. And here is the lab, okay? The lab, so there's, okay, this is a timetable, class A, B, and C, and it will be in building N5, 2355, okay? And we will upload all the lectures on the YouTube, okay? But, you know, I would like you to come and participate and ask questions, you know. It's very important because the lectures cannot cover everything, okay? And the lectures are probably missing a lot of detail. So you come to class, ask questions about various details. So this is the actual, okay, today is, today's the 6th, is it, or the 5th?
26.
Oh, today's the 6th, okay, so it's introduction, course overview. There's no lab next week. And then March 13th, you'll have ROS, okay, Friday. And then after the lecture, you'll have labs. Oh. That would, you know, you would do labs here. Then you would talk about SLAM, and then you will have a lab associated with SLAM and so forth. Okay. So, okay. And there will be no class during midterms week. Okay. And there will be 11 weeks of lecture. And then you will prepare for the project. Okay. So there will be a day where you will perform the task, and there will be judges from outside. Last year we had a person who was in charge of robots at Hyundai Motors. Okay. We also invited someone from Samsung, but because of some complication, he wasn't available. But this year we'll have Samsung, Hyundai Motors, and various company people come to evaluate your project. Okay? So I guess, you can impress upon them and get a job right away or find internship. Okay? So the mission is placed in a random environment, okay, with zones. You need to perceive meaning that you map out, you slam to find out the environment. You have a task, you plan out, and you have to do various manipulations in that environment. And you need to do this thing autonomously. Okay, we saw that. Any questions? Any questions so far? Now, today is a very important day because we're going to ask you to form a team. Okay? So each team will have 3 members. Okay? And team will be given 1 robot per team, a robot like this. The team should check the condition of the robot, and if there are any problems, please tell us. Okay. So once the teams are set, then the team would do the labs together and also the project. Okay. So there's Class A, B, and C. All of this information is uploaded in the KLMS right now. Okay. The grades will be given out not based on teams, but individually. We'll ask the team what each person's contribution to the project or to whatever, and we'll try to figure out, we'll try to evaluate the task that's performed by that individual. Okay, so your team may, was successful or maybe unsuccessful, but if an individual in that team did very well, then he will get a higher mark than the other person. Okay? There is a website for this robot, and if you look at the website, there are various programs and various examples, okay, that you can reference. Okay. So about this robot, okay, it's Jetson rover Ross 1, 2 we can do, but we're probably going to focus on Ross 2, is that right? Okay. There will be with vision robotic arm. So there are cameras on the arm, and there's also a lidar, okay, to give you depth. This is the memory that you have. 6 degrees of freedom, camera, lidar, and it's made out of metal. So if you look, oops. So if you go to the website, there are various examples. Okay. So, because this is available, the task that we are giving to you is going to be more difficult than any of these tasks that you see here, okay? And something very, very unique. So these are, in the first, the second and third week, Professor Myung. Fourth and sixth, Professor Kim Min-jun. He will be giving his lecture via Zoom, okay? And Professor An Yi-jin, planning, and then there's me, okay? And last year, we had some complaints saying that this robot was cheap, and the robot was not working very well, okay? Now, you need to check that this robot is working well, and after that, we're going to give you a robot that is working in a good condition, perfect condition, and you should not complain about the hardware, okay? Because there's a proverb, a bad worker always complains his tools, okay? You need to work in this environment and not blame that, some of these RGB or LiDAR camera is cheap and insufficient for it, okay? Because there's going to be someone who's going to complete the task. Also, the task that we're going to perform for this semester will be something different from last year, okay? It will probably be a little bit more difficult, okay? We haven't really thought about it, but it's going to be more difficult, okay? More dynamic, I should say. Questions? Questions? Yes?
What will be the deadlines of the lab reports?
I think the following week you should have the lab reports. Okay? We'll give you the exact details. Okay. Last year we had 11 teams, so there were 34 people participating. We have a smaller class this year, okay? And I know that some of you are here just shopping, to see whether, this course, this lab course is suitable for you. But if you are certain that you're going to take this course, and if you have someone that you're going to work for certain, please let us know today. Okay. So what we would like is to form this team right away. And last year we did this thing, I think in the first day of the class. Yes. 한국말로 해도 되고 뭐 영어로 해도 되고 뭐 편하게 하세요.
중간이나 주말 발표 혹시?
중간 없어요. 중간
중간 발표나 주말 발표가 있을까요?
기말 발표는 있죠. 기말 발표. So So you're given a project, right? The task, and there's going to be a demo day that the robot has to perform the task that day. And that's it. Okay, so 9 labs, okay, each worth 5 points, and then the final project. 출석은 진짜 안 할 거라고 그래요. 출석. Because every week you have to do the lab. 출석 안 하고 어떻게 랩을 하겠어? 그 5점을 어떻게 받겠어? 그리고 그러니까 so there's 11 weeks of lecture and lab, and then the rest you're pretty much on your own. 그런 구조입니다.
Each lab session is 3 hours. Is it the case that most teams can complete their task within the 3 hours, or are we expected to like prepare beforehand?
I think the 3 hours is enough, but if you need more time, we're willing to give you more time.
Okay.
So we're very lenient on that. Okay. So this course is everything. I mean, we're trying to give you all the opportunities for you to develop a great algorithm for the final day. Because we are inviting guests from outside and we don't want you to look bad. 여기서 okay, raise of. Tell me if you are sure that you're going to be taking this course. So here, okay, and are you a shopper?
저는 그 다른 4학년 시험에 지금 테스트를 보고 와가지고 그게 결과가 어떻게 될지 잘
테스트가 또 있어요? 그건 또 뭐예요?
돈이 많아가지고 그중에 그냥 테스트 보고
그러면 이제 거기에서 이제 합격을 하면 이제 그쪽으로 갈 거고. What about yourself? Okay. Okay. 그리고 이제 혹시 그 외에는 I think the rest are pretty much set. You probably heard about this course from students who took it last year. No, right? So if you've decided who's going to be on your team, please raise your hand. If your team is finalized. Okay. So usually we ask for, 3 members in a team. You have 2. I don't know if you have some. Oh, he didn't come yet. But you have. There's 3. 여기도.
비대면으로 컨택을 했는데 오늘 실제로 뵙고 이야기 나누고 그랬어요. 근데 아마 셋이 그렇게
셋이서 할 거야? 오케이. 저기도 셋 같고. 여긴 2인데? 뭐라고요?
저분하고 이렇게 셋이 같이 하는
또 어떤 저분이래? 그럼 여기는 한 분은 어떻게 되고? 세 사람이에요, 3사람. 한 팀에 3사람. 여기 이렇게 셋? 오케이. Okay, so please let us know. Okay. So we will have 1, 2. 여기 여성분들은 구해야 돼요? 네. 오케이. 근데 확실하게 이거 선택하는 거예요. 그러니까 2 그리고 한 번 더. 오케이. 그러면 뭐 1팀, 2팀, 3팀, 4팀, 5, 저기 혼자 계시는데 부르는 거예요? 알았어요. 하나, 둘. 아, 저렇게 셋이에요? 하나, 하나, 둘, 셋. 저기.
저도 비대면으로 한 분 구했는데 한 분 더 구해야 할 거.
알았어. Okay. Please let us know. The TA will collect the names and the time and the contact number, for instance. Okay. So that's all I have to say today. Any more questions? I mean, I would like all of you to be very, very successful. Okay, because this is sort of a promotional lab for our school to, let the world know that we're doing physical AI. Okay, and you saw the video of last year. That's pretty amazing. That's pretty amazing. Okay, and so I want to help every one of you. Try to give you every opportunity for you to be successful. Yes?
Are we going to have a final report, or is it going to be just them?
Oh, no, you have to write up your final report, and you have to also turn in your code. Not just the code, but you need to describe your code and so forth. Okay. Yes. And you need to make a presentation. So the way it works is we started out with the teams giving a 5-minute presentation, I think, 5 or 10-minute presentation, right? 5-minute, 10-minute presentation. And then we had 3 random environments set up. And we assigned referees or the evaluators for each of the section. And then we assigned teams to these different environments. And the evaluators evaluated each of the teams. Okay? And then you had to turn in your final report. Okay?
프리랩 리포트 같은 것은 없나요? 매주.
없어요. 없습니다. 예. 예.
만약 전체 수강 인원이 3회 배수도 안 되면
그러면은 작년에도 한 팀이었던 경우도 있었습니다. 예. 근데 그렇다 해서 뭐 점수를 좀 더 드리고 그러지는 않았던 것 같아요. 예. 그러니까 한 분이 정말 프로그램 좀 잘 짜는 한 분은 있어야 돼, 한 팀마다. 그리고 인공지능에 대해서 so in your team you need to have good members in your team, okay? A guy who's a good programmer, just a wizard, a guy who knows, these different algorithms, and another guy who could just manage the whole thing very well or, help in any way possible. So if you have 3 dumb members, then that's not a good team. That's not a good team. That has no hope, right? Okay. But each of the labs, the 9 labs, I've including myself, it's geared towards the project. Okay. So if you do the labs very well, you just combine these different algorithms then you'll probably do all right. But that's me saying, okay? That may not be enough, you know. And you need to spend a lot of time on this. And I would also like to say, so there were 11 teams last year, and there were only one team that was successful. And the reason is there are a lot of software that's available for this. If you just use that software, it's not going to work in that environment. You have to tune it for that particular place or for the task that you are preparing for. The parameters has to be changed, okay? All those things has to be done. And you have to do some, learning training as well, okay? And I think that's one of the reasons why it failed, why 10 of the teams failed, whereas one team really did well. Okay. 질문 뭐 혹시 또 comment?
끝나고 앞에 가서 팀
Okay, yeah. What about yourself? I mean, you're by yourself. I mean,
I have two teammates. They're both not here today. In fact, they're probably on their flight to Korea right now.
okay,
Yeah, but I'm sure they will come. Yeah.
okay. So that's it. And of course, this because I think we're going to also share the program that was successful last year. So you're going to sort of build upon that. But this year, we're going to maybe clock you. We're going to put some obstacles and more control tasks. So that you just saw that there was a pick and place that was conducted, but we probably going to have different variety of manipulations that you need to do. Okay. It's going to be a fun course. It's going to be a fun course. Okay, so that's if there's no questions, I'm done. The TA will be here taking your information, okay, your team information, and we'll probably assign you these robots to you, maybe today. Okay. Okay, have fun.